Welcome back. See, I have explained what is isometric projection and what is the difference between orthographic projection and isometric projection. Let us refresh. In orthographic projection, the angle between the planes are 90 degree, whereas in isometric projection, the angle between the planes are 120 degree. Okay. So I'm drawing an orthographic projection of a square 30 mm side. So since the angle is 90 degree, each angle will be 45 degree. So I am drawing the square equally inclined. Okay. Now I have to draw the corresponding isometric projection of this particular square. For that, in isometric projection, this angle is not 90 degree, it is 120 degree. So I have to change this angle from 90 to 120. How is it possible? So we will be applying a simple technique. If you slightly compress this solid from both these ends, we can increase the angle between these two sides. Okay, so I am slightly compressing this, changing the angle. But when you compress this square, the angle will increases, but diagonal length will also increase. Okay, but that is not possible in converting an isometric or orthographic projection from isometric projection. Okay, this is a condition that keeping the diagonal length same, we should increase the angle from 90 to 120. How is it possible? See now we can see this figure. So the angle is 120 degree. This will be 30 and this is 30. So I can say that this is the isometric axis, z axis, x axis and y axis. So how is it possible? I can draw this 120 degree line, 120 degree, these two lines by reducing the length of the side OA to OB. Then it is possible we can increase the angle from 90 to 120 degree, keeping the diagonal length same. I will show you square prism equally inclined, and this is a diagonal length. You can see the diagonal length. Without changing the diagonal length, you should increase this angle from 90 to 120. So I'm taking another square. Usually both are not same dimension. Inserting this to the square. Okay. Now let us check the angle. Sorry, we should keep the diagonal length same. So you can see that now the diagonal length is same, but you can see that this angle is 90 degree, but this angle is not 90 degree because I slightly compress the solid. I am getting the new shape, keeping the diagonal length same, and the angle is 120 degree. But when you make this angle 120 degree, the length of the side reduced to a particular value. All the sides are reduced proportionately. It means that when we convert an orthographic projection to isometric projection, all the lengths are reduced proportionately. Why? Because the angle is 120 degree, or in other words, I can say that in order to make the angle from 90 to 120 degree, we have to reduce the sides, length of the sides proportionately. Okay. Now, you can see that OA is the actual length of the solid. OB is the corresponding isometric length. How it happens? Because we have changed this angle 190 to 120 degree. So the sides measurements get reduced. Okay. So OA equal to actual length is equal to 30 millimeter, OB equal to its isometric length. Why it is less than that of actual length? Because the angle, due to the change in angle. So I can say that isometric length to actual length, OB by OA. How will you find out this ratio? Ratio of isometric length to actual length. Like we can find out this ratio, how much percentage it is reduced. Using this triangle, you can see that using this triangle, I can find out that very easily applying Lami's theorem. For example, see the length AB by sine 15 is equal to OB by sine 45. So I can find out what is a ratio, and you can see that isometric length to actual length using the property of triangle, this will be root 2 by root 3, or this is equal to 0.816 or approximately equal to 0.82. What does it mean? When we convert an orthographic projection to isometric projection, all the side lengths are reduced proportionately by 0.82 times. That is, isometric length equal to 0.82 times its actual length. This is called as the isometric scale. Okay. Isometric length is equal to 0.82 times actual length. But while drawing the isometric projection, we will never use our calculator to find out what is the isometric length corresponding to the actual length. We will never multiply with 0.82 and find out the isometric length. For that, we will construct an isometric scale. So using the scale, we can directly find out the isometric length corresponding to an actual length. It is simple. We just use this triangle OAP, where OA represents the actual length. So I am drawing a line. OA represents its actual length, and angle between OA and OB line is 15 degree. So angle between, I am drawing another line which is of 15 degree angle. So I got, say I draw a line OB. What is the angle OAB? It is 45 degree. So I am drawing from the end A, I am drawing a 45 degree line. Okay. So first of all, I draw the actual length, a line OA. Then I draw a 15 degree line OB. From the end A, I am drawing a 45 degree line. Okay. So what is this length? Suppose if this actual length is say 50 millimeter, that means OA is equal to 50 millimeter. What is this length? OB. OB is equal to 0.82 times 50 millimeter. So this is the corresponding isometric 50 or ISO 50 isometric length. Okay, so rather than multiplying with 0.82, draw a 50 mm line, 45 degree line from here, 15 degree line from here. So this length will represent its corresponding isometric length. Suppose if I want to find out isometric length of a 40 mm line, so mark here 40. How will you find out the actual isometric length? Draw a line parallel to this. So this will be ISO 40. If you mark 30, this is 30 mm actual length, corresponding isometric length is, this will be the corresponding isometric length. Suppose 25 mm, this is 25. How do you find out? Draw a line parallel to this. we can find out this is the corresponding ISO 25. Okay. This is one way of drawing the isometric scale. Rather than, there is another method, the much more easier method, because taking 15-degree line angle is little bit difficult. So I'll be using another method like this. So if this is drawing a equilateral triangle, okay, this angle is draw a horizontal line and another vertical line. Draw a 45-degree line here from this end, 45-degree line. Okay, so I can say this is OA, 45 degree. Okay, now I'm drawing another line, 30 degree. I'm drawing another line, 30 degree. Okay, this angle is 30. So what is this angle? This angle is 15 degree. What is this angle? This is 45, this is 90, so this is 45. Okay. So this OA represents the actual length. This 30-degree line, sure, this will be representing its isometric length. Because this is 15 degree, 45 degree, 15, 45, so this represents its isometric length. Suppose if I am marking here 50 mm, actual 50 millimeter here, how will you find out the corresponding isometric length? This, draw a vertical line, this will be your corresponding ISO 50. Okay, how will you find out the corresponding? Suppose 40 millimeter, mark here 40, corresponding ISO 40 is, draw a line parallel to this, or I draw a vertical line, so this will be your ISO 40. Okay, so this is a construction for isometric scale. So draw a 15-degree line or 45-degree line and complete this triangle. You can find out the isometric length, or draw a vertical line and horizontal line. From here, draw a 45-degree line, another 30-degree line, so that this angle becomes 15 degree, this angle becomes 45 degree. Mark here the actual measurements, say 10, 20, 30, 40, 50, 60, like that. Actual 10, actual 20, actual 30, and 40, 50. Corresponding isometric length will be dropping perpendiculars from all these points. We'll be able to find out the corresponding isometric length. What is isometric length? 0.82 times this value. 40 into 0.8 will be this value. Okay. Is it okay? Clear? Thank you.